Hello friends, welcome to Engineering Study Materials. In this video, we will discuss about the forging. If you like this video, put a thumbs up and subscribe this channel and share this video to your friends to gain knowledge. So let's get into this video. Forging. Forging is perhaps oldest metal working process and was known even during prehistoric days when metallic tools were made by heating and hammering. Forging is basically involves plastic deformation of material between two dies to achieve desired configuration. Here is the diagram showing the forging process. A blank is inserted into the two dies and is forged by using a pressure, and then it is removed to get the forged product.
这个垫片都有字的，大小都有字母的，根据帆布大小可以调节，然后放回去。然后要盘一下，盘着转，这个皮带呢盘着转，你们可以开机；盘不转就不能开机。这是没有梳过的，原来的尺寸，照一下，原来16.313，现在梳过了，看到尺寸吗？15.2，15.3，OK。
Let us see an example for hot rolling process. Rolls, billet. Hot rolling is a process of compressing the metal between two opposite rotating rollers for reducing its thickness. Grain flow in hot rolling. In previous video, we have seen hot rolling process. Let us see the grain flow in hot rolling process. Rolls, undeformed grain structure, elongated grains. Grains are elongated in the direction of rolling and recrystallization process takes place. Deformed grains. Cold rolling. Let us see an example for cold rolling. It consists of two rolls called backup roll and working roll plate. In cold rolling, the billet is deformed in between the two working rolls. The backup roller avoids the bending of working rolls. Grain flow in cold rolling. Let us see grain flow in cold rolling. Rolls, undeformed grain structure, elongated grains. Grains are elongated in the direction of rolling. Grains are not reformed.
The primary type of hot extrusion is direct or forward extrusion. In direct extrusion, the hot billet is loaded into a thick wall container and forced through an extrusion die secured in a holder. The force for extruding is applied by a ram, along with an intermediate reusable dummy block. Metal flow from the die is in the same direction as the forward motion of the ram. Since the surface of the billet length slides along the wall of the container, extrusion force depends on the friction between the billet length and the container and the material. the friction portion of the force can be reduced by using lubrication. Force increases rapidly as the billet is upset to fill the container, then increases further as breakthrough force before extrusion begins. Upon breakthrough, the force declines as billet length decreases until a minimum force is reached. As the billet thins, the force rapidly rises again to continue metal flow radially toward the die opening. Resistance to deformation or force requirements increase markedly as the thickness of the butt or unused billet portion decreases. Hot extrusion is most commonly performed on horizontal hydraulic presses. Hot extrusion presses are usually rated in force capacity, which translates to the amount of pressure applied to the billet. That pressure depends on billet material and temper, its cross-section and complexity, length and temperature, extrusion speed and reduction or extrusion ratio. The extrusion ratio equals the cross-sectional area of the container liner divided by the cross-sectional area of the die openings.
Between direct extrusion and indirect extrusion process. Here extrusion is a metal forming process involving shaping metal billet by forcing it through a die with opening. Here metal billet is a raw material placed into a container of a extrusion press. Here die with opening is mounted at end of container. When hydraulic driven ram presses billet, the metal start to flow through a opening, forming extruded product of required cross section. In direct extrusion process, the extruded metal flows in direction of a ram motion. In indirect extrusion process, the metal flows in direction opposite to ram motion. Indirect extrusion process required lower force than direct extrusion process as there is no friction between billet and inside wall of a container. Direct extrusion process also known as forward extrusion process, where indirect extrusion process also known as backward extrusion process. The material wastage is more in direct extrusion process than indirect process. In direct extrusion process, the force required to release the billet out of extruder is more, wherein indirect extrusion process force required is less. In direct extrusion process, the frictional force is high due to the fact that metal billet must travel entire length of container.
Tube bending is a method of producing shapes by holding or clamping the tube with tooling and applying sufficient force to form the tube to a bend radius while maintaining the tube's cross-sectional shape. For bending to be successful, the tube material must be bent beyond its yield point, which is the material's capability to resist permanent deformation, but not past its ultimate tensile strength, which is the limit of the material's ability to resist tearing. As the tube is bent, it undergoes a distortion so that the material outside the bend is forced to stretch under tension, and the material inside the bend is forced to compress. Between the tension and compression zones is a boundary line known as the neutral axis. The neutral axis is important since bending operations are calculated from its location. Factors important to the successful bending of tubes include tube outside diameter, tube wall thickness, bend radius, and bend location. In a typical press brake bending operation, a piece of metal is placed between the upper and lower dies and formed by means of the force and pressure exerted by lowering the ram. On some press brakes, the ram and upper dies remain stationary, while the bed holding the lower dies provides the force that bends the part. 3 contact points are involved in a bend: the tip of the punch and 2 points on the female die. The material is bent to the desired angle as the punch enters the die. The larger the die opening, the smaller the force required to form a given angle. The principal terms used to describe bending on press brakes are bend allowance, bend angle, bend radius, and spring back. Bend allowance is the pre-bent length of material that must be included in a blank to allow for any deformation that occurs due to the bending operation. The bend angle is usually the included angle of the bent workpiece. It can also refer to the supplementary angle formed by the 2 bent tangent lines. The bend radius is a tangent line where the flat, straight section of the part stops and the radius of the bend begins. Spring back is the tendency of the material to return to its original form. Spring back typically ranges from 2 to 4 degrees.